Welcome to Chapter 3, example number 3. We're going to use previous data from another example, example 2, and that was discussing men's 800-meter run world records. And the first thing we're going to do is we're going to take our data and we're going to plot a scatter plot. And I'm going to use the TI Nspire to do this, so I will bring up the scatter plot and show you what it looks like. Okay, here's the scatter plot, and the way I decided to enter in the data into the calculators, I did the explanatory variable first, which years explain the records in seconds. And that goes always, explanatory variable always goes on our x-axis. And then the response variable, what responds to our explanatory variable, is the world records in seconds, and that goes on your y-axis. And we can see from the scatter plot, it does look like we have a possible linear correlation, a negative correlation. Our data is congregated, decreasing in record as the years progress. So that now that we see we have a possible linear relationship, we should go ahead and perform a least squares regression, which is number 2. And I will use the calculator, the TI Nspire as well, to give you the least square regression line equation. Okay, here's our scatter plot with the least square regression line that has been added in. And you'll notice the TI Nspires are very friendly and give us the equation of the LSRL. It is right there. And from that we can interpret the slope by first identifying it. Here's our slope, negative 0.1408. And how do we interpret that? Well, we would say as the years increase by 1, the records decrease by negative 0.1408 seconds. Now next, number 4 says to plot the regression line on your scatter plot above. Identify the points used to plot the line. Well, if you were to make, you would want to use, it's already done for us, but if you were to pick specific points that would help you plot the line, you'd pick the points that are on the line. So you would pick those two. Probably these two would be good to plot your linear regression line. Okay, number 5 says, what is R squared, and interpret R squared. So I did some 2 variable statistics on the TI Nspire, and it gives me, I did a linear regression test, and what I got was R squared is 0.966322, and that's right here. And it also gave me R is negative 0.983017, but they weren't asking us for R, they want R squared. So R squared is 0.966322. And interpret it. Sorry, excuse Arthur, my dog. What does it say? Well, the interpretation is that 96.6% of the variation in record time is explained. I'm going to kind of run all over the place here, by the least square regression of record time on here. Next question says, construct a residual plot. So I went ahead and used the TI Nspire to construct a residual plot. You'll see that residual plot it's a split screen. It shows you half the linear regression line as well as the residual plot, which is right here. And that's constructed. Is this least squares line an acceptable model for this data? And if we remember back to the previous notes, that if we have no pattern in our residual plot, then it does say that the least square regression line model is a good model for our data. And if I take a look, I don't really see any pattern. I don't see anything kind of curved pattern. So I'm going to say yes. The absence of a pattern. In the residual plot, suggests that the regression line is a good fit. For these data. And our last question is to predict the world record in the year 2005. And so what we need to do is use our linear regression equation. Predicted value equals 381.666 minus 0.1408 times x, and we'll plug 2005 in for x. And we're going to get a predicted value of 99.362. There is a danger here. Remember, we're extrapolating right now beyond the range of data, so this is not necessarily a good prediction. So just remember that. Thank you for joining me for Chapter 3, Example 3.